Is this time the moment of inertia of a uniform rectangular lamina of mass m of length 2l and width 2k about an axis which bisects its length is a third ml squared. Exactly the same formula as the original, okay? Now, please focus in here, this stuff, okay? So, what I want you to focus in on is the fact that, first of all, it's a two-dimensional object, while the rod was considered to be one-dimensional. Once again, go straight away for your definition of rho. Now, this time, it's not mass over length. Can anybody make a prediction on what might go on the bottom? Area. Its units would be kilograms per meter squared. Now, once again, to really beat this home, if I said that my rho value was 3 kilograms per meter squared, and I said, oh, look, here's a piece of sheet metal that's 15 meters squared in area. What's the weight of it? 45. You just multiply rho by the area you're talking about to get its mass. Is that right? That's basically the principle behind nearly everything here. Now, first of all, what is the area? Area is 2L multiplied by 2K, which is 4KL. What's its mass? Its mass is m, and that's over 4KL equals rho. Therefore, rho in turn will be m is 4k rho l, or any other ordering of the letters you want. Okay? Now, we're going to do what we did last time, except we're going to take a little slither of area. So I'm going to take a little sample of area here. Okay? Now, please understand that this area is so thin that the difference between this distance here that I define as x and this distance that I define as, let's call it x bar, they're basically the same thing. It's so tiny. That's how integration works, remember. It's so minuscule, it's considered the same distance away. So, therefore, with all these questions, we're just going to take it as the inside length. And we're taking that this little length here, that guess what I'm going to call the width? Delta x. Good man, great guess, right? Delta x is so minuscule that they're the same distance away from each other, okay? So, what we're going to do next is, we have this, the mass of this is called delta m. We need to find out what delta m is. Delta m is the mass of a rectangular surface whose composition is rho, as in its mass per unit area is rho. So it's going to equal rho multiplied by the area of delta m. What is the area of delta m? We haven't done it yet, by the way. Delta x by 2k. L is actually the axis of rotation. Just to let you know about this axis of rotation, everybody looking at this, it's like it's flipping like that, right? It's not doing that. It's this one is like this because its axis isn't going into the page. So you find that this one's actually flipping over that line there, flipping over and under this line here, as opposed to going this way and that way in the last question. Okay, it's whether it's going into the page or along the page. If it's along the page, it's a flip. If it's into the page, it's a spin around that axis. Is that alright? Now, what we have next is oh yeah, get rid of that, rid of that, rid of that. Okay, so it's the area of this is delta x multiplied by 2k, which is going to give me what? 2k delta x. Okay, so where is it? 2k. So p times 2k delta x. Okay. Next thing we have to do is to find the moment of inertia. I equals the sum of delta m by r squared. Okay, and that equals, what do we always get rid of again? We always try and get rid of the delta m at the start to introduce rho. So what is delta m again? So yeah, I'll do 2 rho k delta x. Now that's just the rho, that's just the m value, okay? That part there is that part there. What part have I left out? I left out the r squared, but the r is known as x squared. Okay? The only thing we're about to integrate, okay? So we have to figure out what is the variable we're actually integrating. So if I that was not smart of me. If I look up the top now, can anybody tell me the limits I'm going to use? Remember, the axis of rotation is dead center. This one here is the axis of rotation. So what are the upper and lower limits? Plus L to the right, minus L to the left. So plus L to minus L. Okay, and then we have 2 rho k, and then finally we have the differentiable part, or the integral part, the one we can actually use is the x squared, and that's the dx. Everything else is constant. So we integrate this and we get 2 rho k, no bother there. What's the integral of x squared? X cubed over 3, and that's working from L to minus L. Yeah? R is defined as the distance of your body away from the axis of rotation, and for every proof we always give it the letter x. Okay? Now, what we have next here, guys, is we're going to integrate this, so we're going to have 2 rho k L cubed all over 3, and then it's going to be minus 2 rho k L cubed over 3. Everybody understood? I just put in minus L cubed there, and it turned into a negative one. Add them together, 4 rho k L cubed all over 3. Now, I'm meant to have a third ml squared, haven't I? What do we always get rid of at the very end? Rho. Rho gets substituted in for the m somehow. So I go to the very top, I go looking, go searching. There we are. You, my friends. That's what I'm looking for. So bring this guy down, keep him in my pockets, and start using them right now. So this means that rho is equal to, actually, it's a direct substitution, isn't it? I have every letter I want, don't I? I have the 4, I have the rho, I have the k, and I have 1 L. Break that L into L cubed into L by L squared, and I can just directly substitute all that in for m. Don't even have to do it the other way, it's much easier this way. A third ml squared is the inertia. Okay. The moment of inertia of a uniform circular disk of mass m and radius r about an axis through a center perpendicular to the plane of the disk is a half mr squared. The language is the biggest problem in these questions. Just the language is hard. Okay, so if I was to draw a circle, yeah, and what I'd say is that the center of that circle is there. If I was to put like a random point on it, what we'd have here, this here, the axis is going into the board through the red dot, and what's happening is it's spinning like that through its center. Is that right? Now, basically like a CD with a pencil going through the middle of it. Okay. Now, it's area, isn't it? It's a 2D object. It's area. We start off like we always start off with rho. Rho equals mass over area. The area of this circle is what, guys? Pi r squared, okay? So rho equals m over pi r squared. isolate m into rho pi r squared. Okay. Next step after that is you draw a diagram, and I'll do it from scratch as opposed to just using the diagram I already have. Okay. So I'll just draw myself a little mark here. Okay, this is the outer circle. Now what I do next is I take a little tiny sample of area that's a certain distance away. So what I do is I basically make a little area like this. See that little loop there? This little shaded region in here that I'm going to shade in green. Okay, like so. That's the sample I'm taking. Like the last question, it's a distance, anybody? X away. And why does the outer distance not matter? Like we call that x1. Why does x1 not matter? It's the green ring is so thin that they're basically considered to be the same distance as each other. Is that right? Now, when you unravel this, okay, it's basically the shape of it's basically the area of a rectangle, if I remember correctly. Yeah, I do. Okay, so what I'm saying is its thickness is what, guys? What's its thickness? That's sorry, I'll get rid of that delta x there. What is its thickness? Can anybody take a wild guess? Delta x is its thickness. Its mass, delta m. So delta m is its mass, okay, and it equals rho times the area of the ring. Now what is the area of the ring? The ring is technically something like this. Or sorry, the ring is technically like a elongated rectangle. Okay? Now, I know if you're really thinking about it, it's more like that. Yeah? But once again, the gap is so minuscule that it's perceived to go straight across. Okay? So what we have here is we have to find the length of this. We have to find the length of this bar to find the area. What's the length? Can anybody take a wild guess at it? 2 pi r it would be, but it's 2 pi x because we're talking about the full inner ring here. Okay? And that would be this side here, which is interpreted as being the same as the outer black ring. So what we say is it's 2 pi x, i.e. the circumference of a circle. Okay? This width here, delta x, yeah? Now we're in business. And all that malarkey there is just the same thing. Okay? Now, what do we always start off with at this stage then? You write down your definition of I. What is I? I equals the sum of m r squared, and then I therefore delta m r squared. Okay, delta m is therefore rho times area. What did we say area was again? 2 pi x delta x. So that delta m in turn, do it in a different color, is going to be sorry, I still haven't found m on its own yet. Oh, so I still haven't found actually no, I did find m on its own. It's grand. So it's 2 pi rho x delta x. Okay, just give me a quick look at that. Yeah, it's an x cubed one. Yeah, we're grand at the moment. Okay. So what's going to happen next is we've left something out here. Can anybody tell me what I've left out? All what I did there was delta m. Delta m is all this part here. What do I have to put in? Another x squared at the end. And if I mix it with the current x in there, what does it turn into? X cubed. Now, integrating. Can anybody tell me it's your axis of rotation working its way out. What is the upper limit? What is the lower limit? R on top, 0 on the bottom. And this thing here, right? So 2 pi rho, integratable part is in blue. Okay, let's do this. 2 pi rho, and then what we have next is our what's going to be x4 all over 4 r to 0, which is simply going to put me as 2 pi rho r to the power of 4 all over 4. What do you need to get rid of? Rho. Where are you? We have very top, isn't it? Mass equals rho pi r squared. Can we make rho pi r squared out of that? We can change this into 2 r squared multiplied by 2 pi rho over 4. Everybody happy enough with that? 2 by 2 is 4. Oh, I see. I made a mistake there. It's the 2. It's the 2 is out. Sorry. There's no 2, and I need to write it differently. Everybody happy with that? 2 by pi rho is 2 rho, 2 pi rho. R squared by r squared is r to the power 4. Directly substitute in the m, and we get 2m r squared over 4. Half it, a half m r squared equals I, and that is